And our final presenter this morning is Maher Alsaaod from the University of Bern in Switzerland, who will bring the session to a close. Thank you.
Thank you very much. My pleasure to present one study of our project, Gesunde Klaue. I am working for the University of Bern, and I am doing as well my PhD project at the University of Bern Ruminant Clinic. The pediogram of the cow, its analysis to detect lameness and food pathology. As we know, the Gait score is the main approach to assess lameness in dairy herds, but this approach has disadvantage. One of them, the low agreement between the observer and within the observer. We have in the literature up to 37 low agreement between the observer, and also in the literature we see delay of lameness detection. The male lame cows we detected up to 10 weeks. The main problem also for locomotion score is not always sensitive to detect food pathology in dairy cows. What we are thinking is combining the objective and subjective gait assessment and providing tool for the observer to improve the inter and intra agreement for lameness assessment, and also to detect cows with food pathology. The aim of the study is using accelerometer with high sampling rate to describe the gait pattern in non-lame cows during walking and determine the difference between contralateral hind limbs using two accelerometers at the same time in case of the clinical lameness and in case of cows with food pathology. The study performed at the ruminant clinic in Bern, and we performed two experiments. The first one, we selected the cow based on their locomotion score. We have 12 non-lame cows and 5 lame cows with unilateral hind limbs with the following pathology. In the experiment 2, we selected the cow not based on their gait score, but based on their food pathology. We have 12 cows with no food pathology and 12 cows with unilateral food pathology. Compare the both experiment we have here. In experiment 1, mixed cause of lameness, we have the first 3 lesions, the lesion located in the foot area, and the 2 lesions here located proximal to the foot area. In the experiment 2, we have different lesions, but all of those lesions located in, we have one location, the foot area. For the clinical gait score, firstly, before each measurement, we filmed the cow, and the films were applied into the accelerometer data as well to the diagnosis, and we used the score system of lower and weary from 1 to 5 score, while 1 is non-lame and 5 is severe lame cows. And we have the cutoff value of 3 as clinical lame cows and more as lame cows. And for improve the reliability of the gait score, to maximize the gait score, we used the mean value of the 3 trained observer independently. For the objective measurement, we used 2 kinds of the accelerometer. The first one is the low-cost accelerometer, and we used the 2 kinds of the accelerometer from the human science. The first one proximal to the low-cost accelerometer to make the synchronization of low-cost accelerometer with the scintigraphy, and also for measurement of the claw acceleration, we fixed the claw from the human science at the lateral claw of the hind limb selected randomly. In this analysis, we measured the acceleration at the claw and also at the metatarsus to define the effects of the gait pattern on the metatarsus by measuring the acceleration at the claw. In this case, we have description of the acceleration in different location. In case of the clinical lameness, we use a 2 accelerometer at the hind limbs, and we calculate the difference between left and right hind limbs in non-lame cows and the difference between left and right in lame cows. And then we compare the two differences. The same design for the cows which selected for the food pathology. We calculate the difference between left and right metatarsus and the difference in cows with food pathology, and we determined the difference of the left and right in cows with food pathology and then compared the both difference. In the experiment 1, we used the seismography just for the orientation, and we used the pedogram, the output from the accelerometer, and in the experiment 2, we used just the pedogram, the output from accelerometer. And for each measurement, we calculated the mean value of 10 gait cycle for each cow. We used the seismography just for understanding the output from the accelerometer, from high sampling accelerometer, and not use it for the clinical application and not use it for any analysis, just for the orientation. And the pedogram is the output from the accelerometer and calculated depends on this form, the root of quarter sum 3 axis. And how it looks, the pedogram of the claw, the blue one, and the metatarsus, the orange one, we have here 4 gait cycle. And if I have one example for one gait cycle, how it's looking, we define it firstly 2 essential points. The first one is the foot load. The foot load is the maximum amplitude when the claw touching the ground, and we define it the second essential point is the toe off, is the maximum amplitude when the claw leaving the ground. And then we calculated the temporal events. We have the stance phase and swing phase. The stance phase is the beginning of the gait cycle. And the gait cycle, we define it as the interval between 2 following foot load. And the stance phase is the beginning of this gait cycle and define it as the interval between the foot load and toe off, as well as swing phase is the interval between toe off and foot load. And these temporal events, we calculated it, we analyzed it as a relative measurement to the gait cycle and not as absolute values. For the gait score, we performed the gait score for 3 trained observers. We have high agreement between the 3 observers, and the difference was maximum half point between the 3 observers. At the first, we described the acceleration at the lateral claw and to the metatarsus. We found, if we have a look at the pedogram of the cows, we have here, in general, we have higher amplitude at the lateral claw compared to the metatarsus. And also we have dilation. If you see here the orange one, there is dilation compared to the orange one, to the blue one of the lateral claw. And the temporal event, the swing phase, as well as the sense phase, were not significantly different between the claw and metatarsus. In experiment 1, we selected the cow based on the gait score, and we have mean value of non-lame cows 1.6, and lame cows we have 3.8, and all the cows we have lame cows in this group. And compare the both difference, we have significantly higher difference in the lame group compared to the non-lame cows. For the census, for example, there is significantly higher difference between left and right metatarsus in lame cows compared to the non-lame cows. One example is the cows with non-lame cows. We have the symmetry between the left and right metatarsus. And if we have a look in cows with lame cows, clinically lame cows, we see the obvious difference between the affected and non-affected hind limbs clearly for everybody. And in experiment 2, we have in cows with no foot lesion had a mean score 1.7, and in lesion group we have the mean score of 3.2. But very important to know here, we have in this group cows with sound cows, non-lame cows, but the cows had a foot pathology. Comparing the difference between the both group, we have significantly higher value of the metatarsus in lesion group compared to the non-lesion group for all the gait cycle variables. For the sense fence, we perform a doc analysis and we see the cut-off value of 2.5% with 100% sensitivity and specificity. In this cut-off value mean if we have difference between hind limbs left and right more than 2.5%, that the cows, the individual cows, has foot pathology without consideration of the gait score. In the summary, we measured the gait cycle variable at the level of the metatarsus with using accelerometer with high sampling rate, and we showed that it could be explored by the acceleration of the claw. For the sense phase as well as the swing phase was not significantly different between the both location, as calculated the difference between metatarsus left and right. We calculated the difference at the core level, so to avoid the variability, the individual variation between the cows, and you use it in the case of the clinical lameness to accelerometer. We showed higher significant difference between the both group as well for the foot pathology. Even the cows has no signs of lameness. This study is a basic information to investigate the effect of the foot pathology in the cows' gaits, focusing in the individual cows for the research and the clinical application. Thank you for your attention, and I am happy for any question.
Great, we've got a question here. Thank you.
Thank you for that presentation. It was really interesting, but I didn't totally get how you actually differentiated between lame and non-lame. Could you explain that again? The thing with the percentage of the stance phase?
Okay.
Was it that?
We have a group of non-lame cows and group of lame cows, and we calculated the difference between left and right in non-lame cows.
What difference?
For each gait cycle variable, the stance phase, the swing phase.
And you combined all these?
Not combined for each for each parameter of the gait cycle. The foot load, the toy off, the swing phase, the stance phase. Compared the difference between left and right, we have value difference compared to the lame cows, and we compared the both difference.
Okay, and both all the parameters
all
were
significantly different.
Okay.
And clinically, lame cows is just to have a look on the pedogram. You see, just if you have the look, you have the difference.
So actually, for your experiment, it was important that the cow was lame on one foot and non-lame on the other one.
Affected, non-affected, yes.
Okay, because you were aiming on this difference between the feet.
Yes.
Okay, thank you.
Great, thank you very much. I think that at that point we will draw the session to a close. Can I ask you all to thank our speakers again? I hope you agree it's been a fantastic morning.